Hello students. So today we will see few problems on LCR circuit. So first he has asked to find current, power factor and phase between voltage and current. So an LCR circuit is given where resistance is 50 ohms, inductance is 10 millihenry and capacitance is 20 microfarad. Connected across an AC source of 200 volt 50 Hertz. So now in 5 steps we will be able to solve this problem. First you are required to find inductive reactance. First you are required to find inductive reactance, that is XL. XL is given by 2 pi F into L. So if I substitute the values, so 2 pi, or you can substitute the value of pi is 3.142, so frequency is 50, L is 10 millihenry, so 3.142, frequency 50, inductance is 10 millihenry, 10 into 10 raised to minus 3. So now if you simplify this, 3.142 into 50 into 2 is 100 into 10 raised to minus 3. So these zeros get cancelled with this. So you will have 3.142 ohms XL. This is first step. Now second we will calculate capacitive reactance. So if I take capacitive reactance, so XC, that is given by 1 by 2 pi F into C. So I will substitute the values again. So this is equal to 1 divided by 2 into 3.142, frequency is 50, capacitance is 20 microfarad, so 20 into 10 raised to minus 6. So now if I simplify this, I will be having XC is equal to, so if I simplify, XC is equal to 50 into 200, 100 into 20, 2000. So I will have 1 by 3.142 into 50 into 200, 100 into 20, 2000, 2000 into 10 raised to 6. I will take this to the numerator, minus 6 I have taken to the numerator. So if we simplify this, 3 zeros gets cancelled. So if I multiply 2, I will have 6.284 into 10 raised to 3. So use calculator and simplify. You will have the answer. So 159.1. So you will have 6.284 will be 159.1 ohms. If you simplify 159.1 ohms, you will get value of XC. Now in third step, you are required to find impedance. In third step, you are required to find impedance. So impedance is given by Z is equal to root of R square plus XL minus XC bracket square. XL minus XC bracket square. So now I will substitute these values. R here is given 50. So this is equal to root of 50 square plus XL minus XC. 3.142 minus 159.1 bracket square. 159.1 bracket square. So you simplify this using calculator. So 50 square, you subtract this and square it, then finally you take the root. You will be having Z value 163.7. 163.7 ohms. Clear, students? First we have found XL, XC, Z. Now in fourth step we will be finding current, power factor and phase. So you can note down the steps, then we will find current. So in fourth step I will have current. So current, fourth, current. So current is given by I is equal to V by Z. I is equal to V by Z, where V is 200 volt and this should be RMS value, that is root mean square value. So if I substitute V is 200, Z I have got it as 163.7. So if you divide, you will have the answer. So current you will have 1.343 ampere. So we have found out the current. Next, power factor. Power factor is given by cos phi. Cos phi we call it as power factor and is given by R by Z. So R we know 50, Z we have found. If I substitute, so R is 50 divided by Z is 163.7. So students, use calculator and find the value of cos phi. So 50 divided by 163.7, you will get 0.3054 is the power factor. So it doesn't have any units. Cos phi is just a number. Then finally phase between voltage and current. So phase between voltage and current. So in last step we will have angle phi. So to find angle phi, you are required to use calculator else log table. So sixth, phase between voltage and current, phase between V and I. So we have got cos phi. Cos phi is 0.3054. 0.3054. Therefore phi is equal to cos inverse of 0.3054. So you can use trigonometric table and find the value of phi. It is 72.2 degree. 72.2 degree. So phase you will get 72.2. So this is how you are required to solve the problem. So first find XL, then XC, then Z, current, power factor, and now in this second problem, students, everything is the same except voltage. So that is, here he has given peak value or maximum value of voltage, that is 283 volt. So in problem, if I had asked to find current, it will be always root mean square value, that is RMS value of current. So first here what I will do, I will convert this peak voltage to root mean square voltage. So you are required to take VRMS. So I will be writing here only. So VRMS is equal to V0 divided by root 2. So V0 is 283 divided by root 2 is 1.414. So if you divide this, you will be having root means square value of voltage. It is around 200 volt. It will be around 200 volt. Now again all the same steps which we had done in the previous problem. So first again we will find XL, that is inductive reactance. So first we will find inductive reactance. Inductive reactance. So XL is given by 2 pi F into L. Now substitute the values. So 2 pi is 3.142. Frequency he has given 50. Inductance he has given 25.48 millihenry. So 25.48 into 10 raised to minus 3. So again you simplify this. 50 into 2 is 100. 3.142 into 100 into 25.48 into 10 raised to minus 3. So use calculator and simplify. You will be having the value around 8 ohms. So you will get around 8 ohms. So this is inductive reactance. Similarly, using capacitive, find capacitive reactance. So if I take second, capacitive reactance. Capacitive reactance. So it is given by XC. So XC is 1 by 2 pi F into C. So now if I substitute 1 divided by 2 into 3.142, frequency is 50, capacitance is 786. So you will have capacitance 786 into 10 raised to minus 6 farad. So again if I simplify this, 50 into 2 is 100. So I will have XC is equal to 1 by 3.142 into 100 into 786 into 10 raised to 6. This 10 raised to minus 6 I have taken it to the numerator. So 10 raised to plus 6. So 50 into 200, 3.142, 786. So students, again you can use a calculator, multiply all these terms, then take reciprocal. You will have capacitive reactance as 4.05. 4.05 ohms. So capacitive reactance. So in third step again you calculate impedance, that is Z. So third, impedance. So Z is given by root of R square plus XL minus XC bracket square. R square plus XL minus XC bracket square. So resistance is 3, XL is 8, XC is 4.05. So if I substitute root of 3 square plus XL minus XC, XL I have got 8, 4.05 bracket square. So again you simplify this. If you simplify this, you will have the answer of Z 4.96 ohms. 4.96 ohms is the Z. Clear students? So you can pause, solve these 3 steps. Then we will again find current, power factor and phase. So in fourth step, we will find current. So current is given by, so current, fourth, I will take current. So current here means it is root mean square value. Current I is equal to V by Z. So here it is RMS value. If we ask find current, if you want to ask maximum value of current or peak value of current, clearly he will mention it in the problem. Else you are required to find root mean square value. So now don't take V as 283 because it is peak value or maximum value. take voltage as 200. So V is 200, Z 4.96. So if you divide, you will have current. So current will be around 40.32 ampere. 40.32 ampere current. Then fifth, power factor. So power factor you are required to find. Power factor is given by cos phi. Cos phi is nothing but R by Z. So R how much it is? 3. Z is 4.96. So 3 divided by 4.96. So if you divide, you will have power factor as 0.6048. Again it is unitless. Then finally phase, that is you are required to find phi. So phi is given by phi is equal to cos inverse of 0.6048. So again use a trigonometric table, you will get the value of phi. So it is around 52.8. 52.8. Clear students? So you can pause, note down the steps, then again we will go for the next. Now in this problem, he has asked to find whether current leads or lags voltage and by what angle. So again given things will be inductance he will give, capacitance he will give, resistance, then he has given frequency. So to find whether current is leading or lagging, he may give voltage or he may not give. Here he has not given the voltage. So now students, here first two steps are same. You are required to find XL and XC. So you can have a circuit diagram for this also, same as for the last two problems we have drawn. So first I will find XL. XL is given by 2 pi f into N. So this is equal to 2 into 3.142, frequency is 50. And L he has given 100 millihenry. So 100 millihenry. So 10 raised to minus 3. So now if I simplify this, 3.142, 50 into 2 is 100 into 100 into 10 raised to minus 3. So if you take these zeros cancel with it, you will have 31.42 ohms XL you will have 31.42. Now in second step, you calculate XC. So XC is given by 1 by 2 pi f into C. So this is equal to 1 by 2, 3.142, frequency is 50. Capacitance he has given as 30 microfarad. So 30 into 10 raised to minus 6. So again I will take this 10 raised to minus 6 to the numerator. So you will have 1 divided by 3.142 into 50 into 2 is 100. 100 into 30 is 3000 into 10 raised to 6. So if you simplify this, you will have XC as, you will get XC around 106.08 ohms. 106.08 ohms you will have the XC. Now see here students. So you have found out XL and XC. Now general phase diagram, if you remember, phase diagram for LCR circuit you will be having in this form. Here you will have R, here XL, here XC, and this angle will be 90. Now always we take current along horizontal direction, that is along resistance always current will be there. So current is denoted in this direction, that is horizontal. Now voltage will be along resultant of this, that is along Z you will be having voltage, that is impedance in which direction you will have. So you can remember this. First, if XL is greater than XC, if XL is greater than XC, so XL is greater than XC, you will have this diagram as this is resistance R, here you will have XL minus XC, and this angle is 90. So resultant of these two, that is Z you will be having in this direction, so you will have Z along this direction. So here I told that current will be along resistance I, voltage will be along resultant of this, that is along Z direction. So voltage you will have in this direction. So this is phase between voltage and current. So now from this diagram you can say that voltage leads current. So you can say voltage leads current I. So students, if XL is greater than XC, then voltage leads current. If I take second case, if XL is less than XC, or you can say XC is greater than XL. Now if XL is less than XC, so XL minus XC you will have negative, or XC is greater, so you will have diagram in this form. So here you will have resistance R, in this direction you will have current. So this will be XC minus XL, or you can say XL minus XC is negative, so you will have in this direction because XC is greater. So resultant, this angle will be 90, so along this resultant you will have Z or voltage in this. Now this angle between current and voltage is phase. The angle between current and voltage is phase. Now here if you observe, V is in fourth quadrant, I is along x-axis, so here current leads voltage. So here you can say current leads voltage. So just by finding XL and XC, you can say that whether current is leading or voltage is leading. Clear students? So you can pause, note down this important point. So if XL is greater than XC, voltage leads current. If XC is greater than XL, current leads voltage. Now he has asked whether current is leading or voltage is leading. So from these two you can say that as XC is greater, so XC is greater than XL means current leads voltage. So I can say that current leads voltage. Now he has asked by what angle, you are required to find angle. So I can say, third step I will take, as XC is greater than XC is greater than XL, current leads voltage. Current leads voltage. Now I will take this phase diagram to find phi. So if I take phase diagram, along this direction I have resistance or current, along this direction I have XC minus XL or XL minus XC. So here I will have Z or voltage, this is phase angle phi. Now if I convert this into a parallelogram, so here this will be equal to again XC minus XL and this will be resistance. So tan phi is equal to XC minus XL by R. So I can use that and find phi or phase. So just I will draw another diagram. So I can convert this into a triangle. So here along this direction I have R, along this direction I have XC minus XL, this is nothing but Z, so this is phase phi. So tan phi will be equal to XC minus XL by R. So to find phase, tan phi I will take XC minus XL divided by R. So even you can take XL minus XC in mod. So I have taken mod means I should get angle positive. Whether current is leading or voltage is leading, I have already denoted. So if I substitute the values, I will have, so tan phi is equal to mod of XC minus XL, that is 106.08 minus 31.42 divided by resistance. So resistance here given as 200 ohms. So resistance is 200. So you simplify this, you will have the value of tan phi. Then again use trigonometric table to find phi. So if you simplify this, so you will have 106.08 minus 31.42, so 74.66 divided by 200. So if you divide it by 200, you will have answer 0.3733. Then use trigonometric table. So phi will be tan inverse of 0.3733. So you will get phi around, if you see trigonometric table, 20.5. 20.5. Clear, students? So in this way we find whether current is leading or voltage is leading. So again few more problems we will see in next session.